Graphene. For the first time in 2040, Game and myself, using the method of mechanical acceleration, separated one sheet of graphene from graphite. Since when graphene has unequal physical mechanical properties, mechanical, thermal, optical, and electrical. So based on above properties, it's attracted more attention in many fields of science and technology. Graphene is a flat layer of monoatomic structures of sp2 bond carbon atoms, which is tightly packed in a hexagonal structures. Graphene is one layer sheet of carbon, which is a flat monolayer of sp2 hybridization carbon atoms located in a honeycomb lattice and having carbon-carbon bond distance of 0.142 nanometers, and the height of on one layer is 0.33 nanometers. Structures of graphene has a stable hexagonal form due to densely packed carbon atoms and sp2 bonds in each lattice, and this bond consists of combination as S, Px and Pey orbitals. The final Pz electrons bond located vertically to a plane of lattice on which the electrical conductivity of graphene depends, and the hybridization of these p bonds contributed to the formation of zone and p zone bands, and also the electronic properties of graphene depend on these zones, with help of which electrons can freely move through the half-filled bands. Thus, the graphene structure consists of densely packed on one layer of carbon atom associated with surrounding atoms of carbon by sp2 hybridization in the shape of benzene ring, and in which each atom donates an unpaired electron for band, and in this case electron can move freely with interference at room temperature, which is high conductivity. Graphene is semi-metal, and lower energy of electrons can pass from the valence to the conduction bands through a small overlap, and this transition occurs without external heat exposure. Also, a certain amount of electrons can be in the conduction band, and in the valence band there is a certain number of holes. Figure shows conduction bands of a cone-shaped structure, and that the valence band and conduction band interpret. The direct point also the manifestation of anomalous quantum Hall effect and the characteristic of relativistic particles, which occur in the process of electron transfers. Compared to other carbon materials, graphene has optical, electrical, and mechanical properties. The optical properties is distinguished by the fact that regardless of the wavelength in the optical zones, graphene absorbs 2.3% of the light intensity. Also, the transparency of graphene depends on the number of layers, that is, a single layers graphene absorbs 2.3% of visible light and has very high transparency of 19%, and the transparency of two layers graphene is less than a single layer, and the difference between them is 2.3%, which is shown in figure. Graphene with different layers have ability different colors and contrasts. Also, graphene layers can be distinguished using the refraction and interference light, and also depending on the different thickness of graphene, you can control the unequal optical properties of this material. Another interesting properties of graphene is the mobility of electrons. In this case, the electric conductivity of a sheet of 2D materials is given by the expression, and the mobility of 2D sheet is theoretically limited to 200,000 centimeter to volt. By acoustic phonons at carrier density is 1,000 centimeter to 140 times more. Compared with copper, the electric conductivity of graphene with a thickness of one layer is much higher. That is, the volumetric conductivity of graphene is 0.96 multiply 10 orders, 6 orders. Thus, graphene can potentially become competitive and replace indium and fluorine tin oxide and other traditional membranes due to its optical and high conductivity properties. The next properties of graphene is the mechanical strength, which has the most rigid crystal structures among all known materials, and the tensile strength and modulus elasticity of graphene 125 gigapixel and respectively its tensile strength reaches 42 Newton meters. And graphene with the same size and thickness, when graphene is approximately 100 times stronger, for example, 1 meter quadrats of graphene can be withstand 4 kilograms of weight. Still in tensile strength range of 250. For example, if it is a hypothetical to take a steel film with a thickness of 3 angstroms and the thickness of a single graphene layer in graphite, then two-dimensional tensile strength of steel give 0.45 nanometers. Also, one of the important properties of graphene is thermal conductivity. The thermal conductivity is 10 times better than copper, which is at room temperature. Copper has 401 Wm minus 1 K, and graphene is approximately 5000 Wm minus 1 K minus 1. In addition, graphene has a high surface area, 2,600 meter quadrats, and these properties allow to be used in microsensors for gas molecules by observing sharp changes in electroresistance in the process of absorption and desorption of gas molecules.